Today we're going to be looking at the 2017 December Gold question, barn painting. So in this question, Farmer John is going to paint a farm of barns, and he's going to paint them one of three colors. So what's going to happen is when he paints them, he wants to make sure that no two barns that are directly reachable are the same color. So what we're going to do is we're going to count the number of ways that Farmer John can paint the remaining cows. So let's go look at the algorithm for this question. So the main way we're going to solve this question is going to be through a DP on a graph. And for the specific code I'm going to be showing you, it's going to be recursion. Of course, DP and recursion are interchangeable, so basically you can rewrite the code with DP. So the main thing we're going to notice is we can turn this into a graph question. And so what we're going to do is we're going to assume if 1 is currently color X, or let's say this color blue, then all of one's children have to be a different color. And the way we're going to do this is we're going to have our recursive function, and we're going to have three main parameters. We're going to have recurse, and then we're going to have the node, we're going to have the color, and then we're also going to have the parent. So parent isn't really necessary if you use visited. I'll talk about this more in the code. So what we're going to do is we're going to set the value of dp node I to the total number of combinations possible for dp node I, or dp node color. And so since we already have some stuff preset, let's say this is purple, this is yellow, this is purple, what we're going to do is we're going to start here. We're going to check some base cases. I'll talk more about that in the code. And we're going to loop through all of our children. So from this point, I'm going to loop through all of my children. And what I'm going to do is I'm basically going to have a second loop here that's going to loop through the three colors. So this is going to be from 1 to 4 max. And then what I'm going to do is I'm going to start here, and I'm going to call the function. So I'm going to call recurse, and then the child, and I'm going to call whatever color this is. And so over here, we're going to basically check. Let's say the current value here is already set to yellow. So we're also going to have an if here that's going to check to see whether or not the color of the node is already the color we assign here. And what this basically means is, let's say I'm counting and I assign this a blue, but it's already colored yellow. What I'm going to do is I'm going to check here, and if this is assigned a yellow, or if this is invalid, I'm going to just make our DP value 0, because that just means it's not possible. And you'll see later in the code, but what we're actually going to do is we're going to multiply the total number of combinations by the number of combinations for every DP. So again, I'll go more in depth in the code, but the basic idea you should know is I'm going to start here. I'm going to find all of his children, and I'm going to color them. I'm just going to recurse down. And when I recurse down, I'm going to color them a different color than my current color. So let's go look at the code for this question. So the first thing we're going to do is we're just going to create our data structures. So I'm going to have the mod, size, I'm going to have adjacency list, I'm going to have DP, and color. So what we're going to do is we're going to read in our input. And so I'm going to resize my data structures, and I'm going to read in my input through the adjacency list for the barns, and then for the colors for the preset barns. And so what we're going to do next is we're just going to recurse 3 different times with the 3 different scenarios. We're going to recurse with the color 1, 2, and 3. And what I'm going to do is, when you typically do recursion, or when you're doing a kind of looping through the graph, you would have a visited. And what I'm going to do instead is, to avoid having this visited array, I'm going to have a parent. So this is just going to be, because we have no cycles, I'm just going to have a parent that's going to point to the previous parent of this current node. And so you could basically just ignore parent and replace it with visited, but for this specific code, I'm going to be using parent. So what I'm going to do is I'm going to have the recursive function, and we're going to check a couple main things. We're going to check if it's already visited, and if it is, then we're going to return. And then we're going to check whether or not it's already been colored, but with a different color. So let's say it's already been colored with a color that is not C, or the current color we want it to be. Then we're going to set our DP value to 0, and we're just going to return. So that just means it's invalid. There's no way to do this. Otherwise, we're going to start by making our DP node C1. So again, we're going to have node be the first element, or the current node, and C be the current color it is. And so what we're going to do is we're just going to loop through the children. So over here, because again I'm using a parent, I'm just going to make sure that my next is not my parent. You can just replace this with if not visited. I'm going to have my mulvi, and what I'm going to do is I'm going to loop through every color, and every time I reach a new color that isn't my current color, because these are my directly adjacent children, what I'm going to do is I'm going to recurse, and I'm going to create the value of mulvi, or the number of different ways. I'm just going to add the DP value, and I'm going to mod the mod. So once we've done that, what we've basically done is we've created the number of possibilities. And so because we're counting the total number of possibilities, every time we loop through, we multiply by the total number and then we do the mod. So by doing this, what I've basically done is I've recursed all 3 possibilities. And then at the very end, what I'm going to do is I'm just going to add all of these together, mod to mod. So this is just going to add DP node 1, and it's going to have the color 1, color 2, color 3, mod, mod, and I'm going to return. And that's the end of our program.